Hi, welcome to my YouTube channel. My name is Lisa Shashkova, I'm a software developer, and today we'll learn what's the difference between BFS and DFS algorithms. First, let's try to understand what do they have in common. What do these letters mean? Both of them are algorithms for graphs traversing. BFS means breadth first search and DFS means depth first search. So both of them describe some order for visiting nodes in a graph. And the main difference between them is that they visit nodes in different order. DFS firstly visits all the children of the node before moving to other nodes. For example, on the first stage of the algorithm, it visits all the nodes which are one edge far from the root node, which is marked red on our picture. On the second stage, it visits all the children of these children, and only after that, it visits node which is 3 edges far from the root node. We have only one node like this in our example. BFS works a bit different. It visits all the paths which go through this node before moving to the node's siblings. For example, here we have only one path through this node. Then we have one node without children. But here we visit the first root from this node, then the second root, and only after that, when we visit all the paths from this node, we move to the next node. It describes just the main idea of these algorithms, but the best way to understand some algorithm is to look into its implementation. We will use, of course, Python because it looks almost like pseudocode and it's easy to understand. How can we implement BFS, breadth first search? For implementing, we need a queue. Queue is a data structure which works like first in, first out. What does it mean? That means that the item which was added first to our data structure will leave it also first, so earlier than all the items which were added later. So it works exactly like queue in a supermarket. If you come earlier, you will buy all the necessary things earlier. If you come later, you will buy all the things later and leave the shop also later. And we will use queue to store next nodes in our graph, which we are going to visit. Okay, let's define this function, BFS, which takes root node. In our case, it's root C. We will implement a queue on our own. We will use a standard data structure list here. So in the very beginning, we add our root node to the queue. You can see it here. And we start iterating. Our algorithm will work until our queue is not empty. What are we going to do on each stage of our algorithm? First of all, we need to pick some element from our queue. So we need to remove the first element from our list. So our list is a queue. We add new elements to the end and remove elements from the beginning of our list. And this is how our queue will work. Okay, we got our element, add it to the result. Mark it as visited. Here we added the result and add all the children of our node C to the queue. So we go through the list of children and add all of them to our queue. What happens on the second iteration? On the second iteration, we get node B, remove it from our queue from the very beginning, and again edit the result and add its child, node A, to our queue. And you can see here that all the children of our root node, which are marked with blue color, are allocated in the queue earlier than, for example, node A and all other nodes. That means that we will consider these nodes earlier than all other nodes. And that will guarantee that our algorithms works exactly like we described. So we visit children, we consider our children earlier than all other nodes. And again, on the next stage, we remove node D, and it doesn't have children, so we skip it. And we'll continue the same iterations again and again. You can see we remove node E and add its children here. Also, we add nodes F and I, and so on and so on. So, what happens after that? After that, when our algorithm is over, we first of all print in some result in exact order which we visited our nodes. And the queue was a data structure which helped us to do it. So for each node, we first visited its children, and only after that moved to their children and then to their children and so on, until we visited all the nodes in our graph. After that, when our queue is empty, we can just return result as a returning value of our function, and that's it. That is how it works. Okay, now let's try to understand how to implement DFS. For the DFS, we also need a util data structure, and in this case, it will be a stack. A stack works on a principle first in, last out. That means that if some item was added to a stack later, it will be the first item to leave. We can compare it as with box with some items. So the best idea to draw stack not horizontally but vertically. So you put some item and then you put the second item, and if you want to pick up the first item, you need firstly remove the second, and only after that you can get some item from the bottom. So also there is a bottom of the stack and top of the stack, and you can use it to implement any other algorithms. And again, we will be using a stack data structure to implement DFS in our graph. How are we going to do it? Let's try to understand. Again, we have the same graph, a root node C, and again we will be using Python standard data structure list to implement our own stack. Again, we will be iterating some actions on each iteration of our algorithm. Until our stack is empty, we remove element from it. Here it isn't a queue, it's a stack, so we remove the last element. So we will be adding elements to the end of our list and remove elements also from the end of our list. Again, now we added the first root. When we have only just one node in our data structure, there is no difference whether we remove it from the beginning or from the end, but later it will become important. Okay, we added our root node, removed it during the first iteration, added the result, and exactly like we did it during the BFS algorithm, we added its children to our stack data structure. What's going next? On the second iteration, the first difference appears. Now we remove not the element from the beginning of our data structure, but from the end. So that means that here we remove node E from our stack. What happens after that? After that we add it to result and we add its children. Okay, and again we added children to the end of our list, And since it's a stack, we need to remove items also from the end of our list. And we can see all the blue routes are still waiting in a stack until we finish our visiting all the paths which go through the E node. We wouldn't start considering blue nodes. And this is the main idea of the DFS. Firstly, we visit all the paths which go through the current node, and only after that we go to, for example, to siblings of the current node. So we continue the same iterations again and again. We remove F and add G, and we remove G, and then we remove E, and so on and so on. And after that, when our stack is empty, that means that we visited all the nodes from our graph, and we can return the result. Okay, now we understand how BFS and DFS work and how to implement them. But what's the main difference between these algorithms? And the answer is pretty simple. We've seen implementations for both these algorithms, and the only difference, in fact, is just one line of code. One line of code which describes which element we should remove from our data structure, from our list. In case of BFS, we remove the first element, and in case of DFS, we remove the last element. And this is the only difference, in fact. If you need to convert one algorithm to another, you just need to change one line of code. And that was mind-blowing for me when I realized it. But yeah, this is how it works. Of course, it's just one line of code during implementation, but, well, there are some other differences as well. So, of course, the most important difference between these algorithms is the main idea. So, the main idea of breadth-first search is that it proceeds nodes level by level, and DFS, depth-first search, proceeds nodes in different order. It follows paths from start to the end, so it considers all the paths which go through the current node. And only after that starts considering other nodes. Also, these algorithms use different data structures. Breadth-first search uses queue and depth-first search uses stack. Time complexity is very similar in these algorithms. Of course, it depends on the data structure you use to store information about your graph. But usually it's big O of n plus e, where n is number of nodes and e is number of edges, which is pretty simple to understand because we need to consider every edge in our graph and every node in our graph. And in some case, we can't say we just need to proceed all the nodes or all the edges, because usually these values depend on each other, because there are graphs, there are complete graphs when all the possible edges exist, and there will be big O square of n of them, which is pretty big number, so we just can't remove edges from here. It will be big O of n plus e in both cases. And of course, these algorithms have different usages. For example, you can use breadth-first search to find the shortest path between two vertices, and you will find it pretty fast, because in BFS, when we consider nodes, the order depends on the distance between the current node and starting node. So on the stage n of our algorithm, where n is the distance between our edges, we will find the exact edge, the exact path, if it exists between these nodes, and that will be the end of our algorithms. In DFS, it will take more time, because we will find this path only after we consider all other paths. Today we learned what do BFS and DFS letters mean, what are the differences between them, how to implement each of these algorithms, and what's the main idea is stored behind these algorithms. I hope this information will be useful for you now when you know how to quickly implement these algorithms and how to quickly convert one algorithm into another algorithms. You can just implement them pretty quickly wherever you need it, for example during an interview or during your usual working day. I hope it will be useful for you. Thank you very much for your attention and see you later in the next video. Bye!